There is a moment in the life of anyone passionate about science when everything you thought you knew about reality simply falls apart in the face of a single devastatingly simple yet deeply disturbing explanation. And this is exactly the kind of moment that Neil deGrasse Tyson, one of the most influential astrophysicists of our era, has the power to create when he decides to dismantle piece by piece everything we consider to be the objective reality around us. Because the naked truth he presents is not just about physics or cosmology, but about the very nature of what we call existing, of perceiving, of being conscious in a universe that operates on scales so absurdly beyond our comprehension that our minds have not even evolved to process it correctly. And when you finally understand what Tyson is saying, when that explanation truly penetrates your consciousness, something fundamental changes in the way you see every object, every person, every moment of your life, because suddenly it becomes crystal clear that what your eyes see, what your ears hear, what your fingers touch, is not at all reality as it truly exists, but rather a grotesquely simplified and filtered interpretation that your brain constructed so that you can function minimally in this incomprehensible cosmos. And if you are one of those who love to have your perception of existence completely recalibrated by devastating scientific discoveries, subscribe to the channel because we are going to dive into a journey that will question literally everything you think you know about what is real. But before we get to Tyson's central explanation that will blow your mind, we need to understand why this question of the nature of reality is so fundamental, and why that so many scientists, philosophers, and thinkers throughout history have become completely obsessed with trying to understand whether there really is an objective reality out there, or whether everything is just an elaborate construction inside our heads. The history of humanity trying to understand what is real begins long before modern science, going back to the Greek philosophers who already questioned whether we could trust our senses, with Plato creating his famous allegory of the cave, where prisoners chained since birth can only see shadows projected on the wall, and believe that those shadows are the totality of reality, without imagining that there is an entire three-dimensional world of real objects out there producing those two-dimensional projections. And this metaphor from more than 2,400 years ago remains absolutely relevant today, because it essentially describes the human condition. We are all prisoners of our limited senses, trying to make sense of a universe that operates at frequencies, dimensions, and scales that we simply cannot access directly. But it was really with the development of modern physics that we began to have concrete scientific evidence that our everyday perception of reality is not only incomplete, but is fundamentally wrong in crucial ways. And one of the first major jolts to that perception came with the discovery of the full electromagnetic spectrum in the 19th century, when scientists like James Clerk Maxwell realized that the visible light that what our eyes detect is just a tiny slice of a much larger spectrum of electromagnetic radiation that permeates the entire universe. Imagine that the complete electromagnetic spectrum ranges from radio waves with wavelengths of kilometers to gamma rays with wavelengths shorter than the nucleus of an atom. And visible light, the one that our eyes evolved to detect, represents less than 1% of this total spectrum. It is as if you were trying to understand an entire symphony, but could only hear a single musical note. So during your entire life, you believed that that note was the whole song. And suddenly, someone reveals to you that there are dozens of other instruments playing simultaneously at frequencies that your ears simply cannot capture. This was the first great revelation that reality contains much more information than our senses can process. But that was just the beginning. The real earthquake in our understanding of reality came at the beginning of the 20th century with the development of quantum mechanics, when physicists such as Niels Bohr, Werner Heisenberg, and Erwin Schrödinger began to investigate the behavior of matter on atomic and subatomic scales and discovered that, at the most fundamental level of reality, things simply do not work according to the intuitive logic we have developed by observing human-sized objects. Subatomic particles can be in many places at the same time in a state called superposition. They can behave as localized or wave-like particles depending on how you observe them. They can be instantly connected across arbitrarily large distances through a phenomenon called quantum entanglement. And perhaps most disturbing of all, the very act of observing or measuring a particle appears to influence its behavior in ways that suggest that quantum-level reality does not exist in a defined state until someone observes it. The famous double-slit experiment demonstrates this spectacularly. When you shoot individual electrons through two slits and not observe which slit each electron passes through, they create an interference pattern on the detector screen as if each electron had passed through the two slits simultaneously like a wave. But the moment you place a detector to observe which slit the electron actually passes through, the interference pattern disappears, and the electrons begin to behave like classical particles, definitely passing through one slit or another. It is as if the universe knows it is being observed and changes its behavior accordingly. And this is not cheap philosophy or pseudoscientific mysticism. These are experimental results replicated thousands of times in laboratories around the world. Albert Einstein was so troubled by these implications that he spent decades trying to prove that quantum mechanics was incomplete, coining his famous phrase that God does not play dice with the universe. But experiment after experiment continued to confirm that at the most fundamental level, reality genuinely appears to be probabilistic and observer-dependent in ways that completely violate our intuition about how things should work. Neil deGrasse Tyson, as an astrophysicist and science communicator, has a particularly powerful way of contextualizing these baffling discoveries within a broader cosmological perspective that makes it all the more disturbing. Because he doesn't just talk about the oddities of quantum physics or the limitations of our senses. He goes further and forces you to confront a much more devastating truth about our position in the universe and how that fundamentally affects what we can know about reality. And the central explanation that Tyson presents, the one that really changes everything, revolves around a seemingly simple observation, but one with profound philosophical implications, which is the fact that the difference between average human intelligence and the intelligence of our closest primate relatives is a difference of only approximately 1 to 2% in DNA. Chimpanzees share about 98.8% of their genetic material with us. And yet this minuscule difference has allowed us to develop complex symbolic language, abstract mathematics, philosophy, art, science, technology, and civilization as chimpanzees. However intelligent compared to other animals, they simply cannot understand calculus, quantum physics, or cosmology. You can try to teach Maxwell's equations to a chimpanzee for decades, and it will never understand why its brain simply has not evolved the necessary neural architecture to process such abstract concepts. And here comes the devastating point that Tyson makes. If a difference of approximately 1% in DNA creates such a huge cognitive gulf between humans and chimpanzees, a chasm where concepts that are obvious to us are completely inaccessible to them, what would happen if we encountered a species or intelligence that was 1% more advanced than us in the opposite direction, an extraterrestrial civilization or an artificial intelligence that had the same cognitive distance from us as we do from chimpanzees? For that superior intelligence, our greatest geniuses, our most brilliant physicists, our most profound philosophers would be the equivalent of chimpanzees trying to understand calculus. And the concepts they would consider trivial and obvious about the nature of reality would be as completely beyond our ability to comprehend as quantum mechanics is. For a primate, And this leads us to the disturbing conclusion that there may be, and probably does, exist a deep structure of reality that is simply beyond the human cognitive capacity to comprehend. Not because we are stupid or haven't tried hard enough, but because our brains evolved to solve specific problems of survival on the African savanna 200,000 years ago, not to understand the fundamental nature of space-time, consciousness, or quantum reality. Tyson often illustrates this cognitive limitation with concrete examples that make clear how grotesquely limited our perception of reality is. Even without invoking exotic physics, he points out that humans can only see light at wavelengths between approximately 400 nanometers and 700 nanometers. Other animals, which means we are completely blind to heat. Bees can see ultraviolet light and detect polarization of light, allowing them to navigate using patterns in the sky that are completely invisible to us. Sharks have electroreception that allows them to detect tiny electrical fields produced by the muscles of other animals. Bats navigate using echolocation at ultrasonic frequencies by building a three-dimensional map of the world through sound in a way that we don't even have the appropriate vocabulary to describe because it is a sensory modality that we simply don't possess. And pigeons can detect the Earth's magnetic fields to navigation. So the entire reality perceived by all of these species simultaneously contains layers and layers of information that are completely inaccessible to the unaugmented human senses. Imagine trying to describe the experience of seeing colors to someone who was born completely blind. No matter how detailed your description, you will never be able to truly convey the qual, the subjective experiential quality of seeing red or blue. And likewise, there may be entire aspects of reality that we simply don't have the sensory or cognitive machinery to access or understand, not even in principle. And there you have it. Thinking about all these limitations of human perception and wondering where you are watching this video right now, comment on your city or country, because it is fascinating to think that people from all over the world are having their perceptions of reality confronted simultaneously, while each one is limited to the same senses and same cognitive restrictions. The situation becomes even more perplexing when you consider not just the sensory limitations, but the fundamental cognitive limitations of human brain processing. Neuroscientists have discovered that a huge amount of what we think of as direct perception of reality is actually the brain's active construction and interpretation, not a passive recording of what's out there. Your brain is constantly creating predictive models of the world and using sensory information primarily to correct and update those models, not to build them from scratch every moment. There are classic demonstrations of this, like the blind spot on your retina, where the optic nerve exits the eye and doesn't. There are photoreceptor cells. You literally have a hole in your vision, but you never notice it in everyday life, because your brain simply fills that area with plausible information based on the surrounding context. It is literally manufacturing part of what you see without telling you, and this is not an isolated case. Studies show that only about 10% of the information your visual cortex processes comes directly from your eyes. The other 90% comes from other parts of the brain making predictions and interpretations. You are not actually seeing the world as it is. You are seeing a simulation constructed by your brain that is generally but not always consistent with the sensory information coming in. Optical illusions work precisely because they expose the shortcuts and assumptions that your brain uses to construct your conscious experience of reality. When you see that famous image that can be interpreted as two faces in profile or as a vase, depending on how you focus your attention, the sensory information going into your eyes is exactly the same in both cases. But your conscious experience changes dramatically because your brain chooses to interpret and construct the scene in different ways. What this reveals is that your subjective experience of reality is at least less about internal processes of construction and interpretation than about passive detection of external stimuli. You are living inside a simulation created by your brain, and that simulation is based on real sensory information, but is fundamentally a construction, not a transparent window into objective reality. Tyson takes this reasoning even further when he discusses cosmic scales and how completely inadequate our intuition becomes when we try to think about the very big or the very small. Human beings have evolved to operate on a very specific range of spatial and temporal scales, time scales from fractions of a second to a few decades. And our intuitive physics, the common sense physics we learn from interacting with the world as babies, works reasonably well in this intermediate range of scales. But the real universe operates on scales ranging from the Planck scale to approximately 1.6 times 10 to the power of minus 35 meters, which is absurdly smaller than anything we can visualize, up to potentially infinite in the case of a spatially infinite universe, a difference of at least 60 orders of magnitude, and our scale. Everyday human life falls right in the middle of this logarithmic spectrum. We think we understand how things work, because human-sized objects behave in predictable ways according to Newton's laws. But when you go to very small scales, we enter the quantum regime where superposition, entanglement, and indeterminacy dominate. And when you go to very large scales, we enter the relativistic regime where space and time curve. Simultaneity becomes relative and counterintuitive effects, like time dilation, become significant. And on cosmological scales, the very fabric of space-time is expanding, causing distant galaxies to move away from us faster than the speed of light, not because they are moving through space, but because the very space between us and them is growing. Infinite dimensional Hilbert space. And this strongly suggests that we are approaching the limits of human cognitive ability to understand fundamental reality. The question of consciousness adds another layer of disturbing complexity to all of this, because not only are we trying to understand the physical reality out there, but we also need to understand how on earth the subjective reality of consciousness arises from physical processes in the brain. The so-called hard problem of consciousness that the philosopher David Chalmers articulated, which is to explain not just the neural mechanisms that enable information processing and behavior, but why there is something that is like being you. Why there is an internal subjective experience, qualia, the red of seeing red, the pain of feeling pain, rather than it all just being information processing. Without associated experience, neuroscientists have been able to map many correlations between brain activity and conscious states. We know that certain areas of the cortex and structures, such as the thalamus, are crucial for consciousness. We can even predict with some accuracy what subjective experiences a person will have based on patterns of neural activation. But this still does not explain how or why physical processes of neurons exchanging chemical and electrical signals give rise to subjective experience. There is an explanatory gap that seems fundamentally different from other scientific problems. When we explain how DNA encodes proteins or how stars fuse hydrogen into helium, it is not. There is no residual mystery as to why this is so. But even a complete explanation of all the neural mechanisms of consciousness still seems to leave open the question of why there is such a thing as having these mechanisms functioning. And some philosophers and scientists argue that this may indicate that consciousness is a fundamental aspect of reality that cannot be reduced to or explained purely in terms of physics, a position called panpsychism, which suggests that proto-conscious properties may be present at some level in all matter, while others argue that we simply do not yet have the correct conceptual framework, and that future discoveries in neuroscience and physics will eventually close this explanatory gap. But Tyson's point is that regardless of which view is correct, the simple fact that we are so confused about the nature of our own consciousness, the thing we should know most intimately because we experience it directly in every waking moment, suggests that there may be fundamental limits to what we can understand about reality using only our current cognitive capabilities. So when we put all these pieces together, the picture that emerges is deeply humbling and disturbing, We do not have direct sensory access to most of the spectrum of physical phenomena happening around us. What our senses can detect is heavily processed and interpreted by the brain before reaching consciousness, essentially creating an internal simulation that is only partially based on external information. Our physical intuition only works on a narrow range of scales and completely fails when we try to understand the very small, the very large. Our cognitive capacity was optimized by evolution to solve practical problems of survival, not to understand fundamental truths about reality. And there may be concepts and aspects of reality that are simply beyond our ability to understand, just as calculation is beyond the capacity of a chimpanzee. So what we call reality is at best a useful approximation constructed by brains that evolved to function in a very specific environment at very specific scales, not a transparent window into the true nature of things, and this realization is what Tyson calls humility. This realization should make us much more cautious about claims to have discovered the ultimate truth about anything, and much more open to the possibility that we are fundamentally mistaken about aspects we take for granted. And if this perspective is making you rethink literally everything about your existence, leave a like, subscribe to the channel and turn on notifications because we have many more of these disconcerting revelations about the nature of reality for us to explore together. But there is an additional dimension to this story that Tyson often mentions that makes it even more dizzying, and that is the question of whether we could be living in a computer simulation created by a much more advanced civilization. And before you dismiss this as absurd science fiction, understand that several respected philosophers and physicists argue that this is a possibility that we should take seriously for well-founded reasons. The most famous simulation argument was presented by philosopher Nick Bostrom in 2003, and it works like this. Assume that it is technically possible for a sufficiently advanced civilization to create conscious computer simulations of entire universes, or at least sufficiently large regions of space-time, with conscious inhabitants who do not know they are in a simulation. If this is possible, and if at least some advanced civilizations decide to create many such simulations for scientific or entertainment or other reasons, then mathematically, the number of simulated realities would vastly outnumber the number of base realities because a single advanced civilization could create millions or billions of simulations. So if you wake up in a conscious reality without knowing beforehand whether you are in the base reality or in a simulation, Bayesian probability strongly favors that you are in a simulation simply because simulations are numerically much more abundant if the initial assumption is true, and the initial assumption of technical feasibility does not seem absurd when you consider the rate of progress in computational power, following something like Moore's law doubling approximately every 18 months for decades, and recent developments in artificial intelligence where neural networks are beginning to demonstrate surprisingly complex emergent behaviors. So unless there is some fundamental barrier that prevents conscious simulations, or unless if advanced civilizations universally decide never to create such simulations, or unless civilizations typically destroy themselves before reaching technological capacity to create detailed simulations, mathematically it seems more likely that we are in a simulation than in base reality. And some physicists, such as James Gates, have found mathematical structures in fundamental physics equations that look suspiciously like error-correcting codes used in computing, leading them to speculate whether this could be evidence of a computational structure underlying reality. Tyson generally presents the simulation hypothesis not as something we must necessarily believe in, but as a perfect example of how our intuitions about reality can be completely wrong, and how asking deep questions about the nature of existence quickly leads us into territories where we have no definitive answers. And what is most interesting is that from a practical point of view, the simulation hypothesis can be unfalsifiable. Because if the creators of the simulation are sufficiently advanced, They could, in principle, detect any experiment we try to do to test whether we are in a simulation and adjust the parameters of the simulation to hide evidence or simply turn off that branch of the simulation. Then we could be in a situation where a fundamental question about the nature of our real age is in principle unapproachable experimentally, not because we don't have enough technology, but because the structure of the problem makes it impossible to distinguish between hypotheses. This raises deep philosophical questions about what it means for something to be real. If you are in a simulation, but there is no way to detect it, and your experience is indistinguishable from being in a base reality, in what sense is it important or relevant that you are simulated? Do your conscious experiences still exist and have value and meaning to you regardless of the substrate they are running on? A conscious character in a simulation suffers less than a person. On the basis of reality, if both experience the same pain, these questions mix metaphysics, ethics, and philosophy of mind in ways that our traditional conceptual frameworks have difficulty dealing with. And Tyson uses this to illustrate how even our questions about reality can be poorly formulated because we are using conceptual categories that may not adequately capture the true nature of things. Another fascinating aspect of Tyson's perspective on reality comes from modern cosmology and our understanding of the structure and composition of the universe on a large scale. Because when we measure all the known sources of matter and energy in the universe using various independent techniques, such as observations of the cosmic microwave background, rotation of galaxies, gravitational lensing, and the dynamics of galaxy clusters, we discover something absolutely shocking. The ordinary matter that we are made of, protons, neutrons, electrons, the entire periodic table, only represents approximately 5% of the total content. Of mass energy of the universe, there is overwhelming gravitational evidence for something called dark matter that interacts gravitationally but does not emit, absorb, or reflect electromagnetic light of any wavelength that we can detect. And this mysterious dark matter makes up about 27% of the universe. And then there is something even stranger called dark energy that appears to be a property of empty space itself and is causing the accelerating expansion of the universe. And this dark energy makes up about 68% of the total contents of the cosmos. So let's do the math. Roughly 5% is ordinary matter, 27% is dark matter that we don't understand, but at least we know is there due to gravity. And 68% is dark energy, which is even more mysterious. This means that 95% of the universe consists of things that we don't know what they are. We don't know what they are made of. We don't know why they exist. We only know that they must exist because otherwise our observations don't make sense. Imagine a zoologist who studied 5% of the animals on Earth, and the other 95% are creatures that he has never seen them and has no idea what they look like. This is literally the state of modern cosmology regarding the contents of the universe. And Tyson points out that this should leave us deeply humbled about claims to understand the fundamental nature of reality when we don't even know what the vast majority of the universe is made of. There is also the disturbing question raised by quantum physics about the role of the observer in reality. And here we need to be very careful to distinguish between legitimate physical interpretations and speculative philosophical extrapolations. Copenhagen associated with Niels Bohr suggests that collapse happens when a quantum system interacts with a classical measuring apparatus. But this raises the question of where exactly the boundary between the quantum world and the classical world lies. Other interpretations, such as Hugh Everett's many worlds, eliminate collapse completely and propose that all possibilities in the wave function are equally real and manifest in different branches of the universe that can no longer interact, essentially creating a multiverse structure where all possible outcomes happen in parallel realities. And there are more exotic interpretations like Bohm's theory of hidden variables or the decoherence-based interpretation of quantum information. The crucial point is that almost a century after we developed quantum mechanics and used it to make experimental predictions, with precision unprecedented in the history of science. We still have no consensus on what the theory is actually telling us about the nature of reality, which suggests that we are either asking the wrong questions or the true answer is beyond our cognitive capabilities. Ives to articulate and understand. Tyson often mentions that when quantum physicists are asked about the meaning or interpretation of quantum mechanics at conferences, the standard advice is to shut up and calculate, focusing on the computational and predictive aspects of the theory, and avoiding deep interpretative questions precisely because we do not have satisfactory answers. So what do we do with all this fundamental uncertainty and limitation about the nature of reality? And here, Tyson presents a perspective that is simultaneously humbling and empowering. On the one hand, we must honestly recognize that our understanding of the universe is deeply limited and incomplete, that the tools we have, our senses and our brain, and the scientific method, are incredibly powerful but also have fundamental limitations, that there may be aspects of reality that we will never be able to access or understand with our current cognitive capabilities, and that we must maintain a healthy dose of epistemic humility about our theories and models by recognizing that they are useful approximations, not absolute truths. On the other hand, this does not mean that we should fall into relativism or nihilism and conclude that since we cannot know objective reality completely, then all perspectives are equally valid. Because clearly some theories and models make much better predictions than others, quantum mechanics may be strange and counterintuitive, but it works with astonishing accuracy to predict experimental results. General relativity can challenge our intuitions, but allows us to calculate GPS satellite orbits with centimeter precision. Evolutionary biology can be complex, but it coherently explains an enormous amount of observational data in genetics, paleontology, biogeography, and comparative anatomy. So even if we don't have direct access to objective reality, and even if our theories are approximations limited by our cognitive biology, we can still make real progress in understanding patterns in the universe and building ever more accurate and comprehensive models. And this genuine scientific progress over the last 400 years, since the scientific revolution, is evidence that there is an objective reality out there with structure and regularities that we can discover and map even if imperfectly. Tyson also likes to point out that part of the beauty and wonder of science comes precisely from the fact that we have discovered that the universe is so much stranger, vaster, more complex, and more surprising than we could ever have imagined using just armchair philosophy or everyday intuition. Who would have guessed that light is simultaneously a wave and a particle? That time passes more slowly near massive objects? That galaxies are moving away from each other in accelerated expansion? That the positions of particles are fundamentally probabilistic, non-deterministic? That holes blacks exist where time and space curve infinitely? That the observable universe contains approximately 2 trillion galaxies each, with hundreds of billions of stars? That our DNA is about 50% identical to the DNA of a banana, showing common ancestry of all terrestrial life? None of these discoveries came from just thinking about the problem abstractly. They came from careful observations, controlled experiments, precise measurements, and building mathematical theories that make testable predictions. So Tyson's message is not that science is useless because we will never have perfect knowledge, but rather that science is the best tool we have to gradually peel back layers of ignorance and bring us closer to a more accurate understanding of reality, while recognizing that there will always be more to discover and that we may be fundamentally limited in some directions, and that commenting below which of these scientific revelations surprised you most, or which concept you are still trying to process, would be a fantastic way to be part of this community of people fascinated by the mysteries of the cosmos, trying to understand their own existence. There is an additional aspect of Tyson's view that is particularly important, especially in discussions about science and reality in modern times, which is the crucial distinction between healthy skepticism and evidence denial. True scientific skepticism means examining claims critically, demanding evidence commensurate with the extraordinariness of the claim, being willing to change one's mind when sufficient evidence is presented, and recognizing the difference between legitimate scientific uncertainty and well-established theories. For example, when we say that evolution is a theory, we are not using theory in the everyday sense of hunch or speculation, but in the scientific sense of well-tested and confirmed explanatory framework that integrates a vast amount of evidence of multiple independent disciplines. Gravitational theory is also a theory in this sense. Just like the atomic theory of matter, no reasonable person doubts that gravity exists or that matter is made of atoms just because they are called theories. And yet we see with increasing frequency people confusing deep philosophical limitations of human epistemology with permission to deny overwhelming scientific evidence about climate change, the effectiveness of vaccines, the age of the Earth, or the existence of viruses. The fact that we cannot have absolute 100% knowledge about anything does not mean that all statements are equally probable or that evidence doesn't matter. There is a huge difference between saying we don't know everything about reality because our senses and cognition are limited, and saying, therefore, I can ignore decades of scientific research and experimental data because nothing is really knowable. The first is serious philosophy about limits of human knowledge. The second is intellectual bad faith or conceptual confusion. Tyson is very clear that when he talks about cosmic humility and limitations of human perception, he is not giving ammunition to deniers of established science, but rather contextualizing the scientific enterprise within a deeper appreciation of how difficult and impressive is that we managed to learn so much about the universe despite our limitations. So let's summarize what we've been through on this dizzying intellectual journey. We start with the everyday realization that we are experiencing reality directly and objectively through our senses. Then we discover that our senses capture only a tiny slice of the full spectrum of physical phenomena happening around us, that other species have sensory capabilities that surpass us in several dimensions by detecting aspects of reality completely invisible to us. We move on to understand that even that small slice of sensory information that we can detect is heavily processed and interpreted by the brain, essentially creating an internal simulation before of reaching consciousness. That quantum physics reveals that at the most fundamental level, reality works in completely counterintuitive ways that violate our common sense physics. That when we try to think about very small or very large scales, our evolutionarily developed intuition for human scales completely fails. That the difference between human intelligence and primate intelligence is small, genetically, but huge cognitively, suggesting that there may be concepts fundamentally beyond our ability to understand, just as calculation is beyond the ability of chimpanzees. That we know no more than 95% of the UIT, that the universe is made by taking into account dark matter and dark energy. That we do not even have consensus on what quantum mechanics is telling us about the nature of reality, despite a century of successful use of the theory. That we do not understand how consciousness emerges from physical brain processes, creating a difficult problem that may indicate limits in what we can explain scientifically. And that we must balance epistemic humility about our limitations with recognition that the scientific method still allows us to make real progress in mapping structures of reality, even if imperfectly. It is a journey that begins with certainty, naive, undergoes disturbing deconstruction, and eventually arrives at a more sophisticated position of humble confidence, where we recognize both what we know and what we don't know, and probably never will know. And this transformation in the way you think about your own existence and the nature of the reality around you is exactly the kind of shift in perspective that makes science and philosophy so profoundly valuable. Neil deGrasse Tyson's explanation of all this is not just a set of disjointed scientific facts, but a coherent narrative about the human position in the cosmos. We are a species that arose by blind evolutionary processes on a small planet, orbiting an ordinary star on the outskirts of a typical galaxy, in an inconceivably vast universe. Our brains and senses evolved to solve practical problems of survival on a very specific range of scales. Not to understand cosmic truths, and yet through curiosity, creativity, collaboration, rigor, methodological and technological tools, we have been able to discover extraordinary things about the nature of reality that go far beyond what any individual could discover with just their unaugmented senses and intuition. We have discovered that we are literally made of stardust, that the heavy atoms in our bodies were forged in the cores of stars that exploded billions of years ago, scattering elements across the cosmos. We have discovered that life on Earth shares common ancestors and is connected by a family tree that dates back to approximately 3.7 billion years ago. We discovered that the observable universe arose from an extremely hot and dense state approximately 13.8 billion years ago and has been expanding and cooling ever since. We discovered mathematical laws such as general relativity and quantum mechanics that describe the behavior of matter and energy with incredible precision, even as they defy intuition. We discovered thousands of planets orbiting other stars, expanding our understanding of planetary systems and possibilities for life elsewhere in the world. Universe, all of these scientific discoveries are real and represent genuine progress, even if our understanding is incomplete. And even though there may be aspects of reality fundamentally beyond our cognitive reach, and this combination of impressive achievement with humility about limitations is the essence of the mature scientific perspective that Tyson articulates so well. So what do you personally do with all this disconcerting information about the potentially delusional nature of your everyday perception of reality? One answer would be existential angst and paralysis. If I can't trust my senses, and if my understanding is so limited, then how can I make decisions or live meaningfully? But that would be a mistaken conclusion, because even though your perception is a limited brain construct and not a transparent window into objective reality, it is still a functional construct that allows you to effectively navigate the world. Your subjective experience of colors still corresponds systematically and reliably to wavelengths of light reflected by objects. Your sense of solid objects still corresponds to stable configurations of electromagnetic fields between atoms. Your emotions and relationships and experiences of joy and suffering are genuine and important, regardless of the underlying metaphysical substrate. So there is no need for nihilism or hopelessness. Instead, the appropriate response is a form of tempered wonder. Wonder because the universe has turned out to be so much stranger and vaster and more surprising than we could imagine. Tempered because we recognize our limitations and maintain humility. This is the position of double consciousness that characterizes sophisticated scientific and philosophical thinking, functioning effectively on the everyday practical level while maintaining broader perspective on cosmic context and epistemological limitations. And if you've been able to follow this entire intellectual journey thus far, congratulations, because this is the kind of rigorous mental exercise that genuinely expands your capacity to think about deep questions of existence and reality. Neil Tyson often ends his presentations on these topics on a note of optimistic inspiration. Despite all the limitations and uncertainties discussed, he points out that the history of science is a story of humans repeatedly overcoming apparent limitations. We knew nothing about cells and microorganisms until we invented microscopes that extended our vision to tiny scales. We couldn't detect radio waves from the cosmos until we built radio telescopes that heightened our senses to new frequencies. We couldn't see detailed structure of other galaxies until we launched the telescope Hubble Space. Outside Earth's turbulent atmosphere, we couldn't measure minuscule distortions in space-time caused by gravitational waves from colliding black holes billions of light years away, until we built incredibly sensitive detectors like LIGO. Each of these technological innovations effectively gave humans new senses and new heightened cognitive capabilities, allowing us to at least partially transcend our biological limitations. So while we may never completely overcome fundamental cognitive constraints imposed by the architecture of our brains, we continue to push the boundaries through ever-increasing instruments, sophisticated technologies, more powerful mathematics, computational algorithms, artificial intelligence, and possibly in the future, brain-computer interfaces or other forms of cognitive augmentation. Then the narrative is not one of pessimistic resignation, but one of realistic ambition. We honestly recognize our limitations as we work creatively to transcend them, and this project of scientific and technological discovery continues to generate genuine wonder and knowledge about the nature of reality, even as we know there will always be more mysteries beyond the horizon. Current zone of human understanding. And there is something profoundly beautiful and inspiring about a species that can recognize its own cognitive and sensory limitations while simultaneously working tirelessly to overcome them. It is a form of heroic humility that characterizes the best of science and philosophy. And if these ideas have transformed your perspective on reality and existence as much as they have transformed mine over the years of studying and thinking about these topics, share this video with friends who also love having their minds expanded by deep science, and comment on which aspects of this discussion resonated most with you, or what questions about reality are you still struggling to process, because this journey of discovery is so much richer when we can share and discuss these ideas with other curious minds, also trying to understand the mystery of conscious existence in a vast and strange cosmos.